What up, dogs? First video of 2022. It's gonna be exciting. The Chapter 7 Honors Geometry review video. I've got my little morning snack here, the pure protein from the Costco. I'm a member, all right? So I got the big pack. It was on sale. It's awesome. Let's go. We'll start with a proof. There's one proof on this test. You have no choice but to do this proof, okay? So we'll get it out of the way. And the rest will be, algebra and other awesome things. So I've got BC is perpendicular to AD. That would give me right angles, right? Boom, right angles. What do I know about all right angles? They are congruent. That's awesome. So I've got one pair of congruent angles. I didn't even look ahead at my proof. I just went for it. I want to prove A and D to be congruent, okay? Angle A is congruent to angle D. So I want to get a pair of angles congruent. Either I prove triangles congruent, which these certainly do not look like they're going to be congruent, right? Or I use that no choice theorem. So if I got one angle pair congruent from my given, and I was just able to get those right angles congruent, do I have two pairs of angles congruent? Boom, yes. No choice theorem gets me the third. Let's write it up. So I got my given. Then I've got my right angles first. How about I call these 3 and 4 for a little less writing here? Angle 3 and angle 4 are right angles. And that would be because the definition of perpendicular. Step 3, I can state that these two angles, angle 3 is congruent to angle 4 because all right angles are congruent. And then number 4 here, no choice theorem. Angle A is congruent to angle D for my proof. No choice theorem. That's it. First proof out of the way. Only proof we need to know. That style, right? We're gonna have some angles. No choice theorem. The diagram's gonna look different. What you're given is gonna be different, but same kind of general idea. All right, let's keep going here. Name the polygon with 14 diagonals. Bro, I don't know why I threw that in there. All right, so 14 diagonals. What's my diagonal formula? So diagonal is equal to n times n minus 3 all over 2. Make sure you're writing down your formulas correctly, which are on the test, by the way. And I've seen some people write down the wrong formula, like make a mistake. It's right there for you. Okay, so I have 14 diagonals. That would be D. I don't know my number of sides. It says name the polygon. Okay, name the polygon. So if I find my number of sides, then I can get the name of the polygon. I'm going to multiply by 2 first to get 28 equals n squared minus 3n. So I multiplied by 2, and I distributed that n, right? So we're going to set this equal to 0, and I'm going to have n squared minus 3n minus 28. What multiplies to negative 28 and adds to negative 3? Well, that would be negative 7 and positive 4. Cool. So in this result, or in this case, we have n equals 7 and n equals negative 4, right? I ran out of a little room there. I can't have negative 4 sides, but I can have 7 sides. That is a heptagon. Ooh, the dreaded 7, right? The dreaded 7. There it is. Done. Awesome sauce. 3 points here. If I got down to n equals 7 and I didn't know the name of it, I'm going to lose a point. So know the names of those from that chart. All right, find the measure of the interior and exterior angle of a regular 16gon. Well, interior and exterior. Which one's easier to find? Well, I know that one exterior angle is equal to 360 divided by the number of sides or angles that I have. I have 16 sides. How about I just do 360 divided by 16? Cool. I think that's 20, but I'm going to double check. Well, 22.5. Okay. So, 22.5. Cool, cool. I like it. All right. That's one exterior. Part of it done. How do I get the interior angle? Well, I know in any polygon, whatever it is, I'm drawing it open-ended, right? Could be 5, 6, 7. I just drew like 3 sides of a polygon. I know that this one's 22.5. How am I going to get my interior angle? 180 minus that 22.5 is going to give me the, what is that, 157.5? Is that right? I had to double check just to make sure. I don't want to make an error. I've done that before in these videos, and I apologize when that happens, okay? Call me out on it. If you see an error, feel free to shoot me an email. Try not to, shame me too much in the comments, okay? I'm sensitive, right? Shoot me an email. I'll address it in the description if there's an issue. But that would be my interior. I got my exterior of 22.5 degrees. We're in business, dogs. All right. Find the sum of the interior angles of a decagon. So it has a decagon, that's 10 sides. 10 sides. I don't know why I put the dash there. All right. The sum of the interior angles. Well, the sum of the interior angles is 180 times n minus 2. So I'm just going to substitute 10 in. So 180 times 10 minus 2. So 180 times 8. 180 times 8. Let's see if we can mental math this. 800 plus 160 was 9. I don't know. 960. Whatever. 180 times 8. 1440. I don't even know what I was doing, bro. 1440. I was trying. I need to have the rest of this guy. I'm gonna pause. Get my brain food going. Then I can do mental math again. Okay. But that's it for this problem. Sum of the interior angles. By the way, what's the sum of the exterior angles? Sorry, I'm talking about food in my mouth. I just thought of the question. Sum of the exterior angles, always 360. Always 360. All right. How many sides does a regular polygon have if the interior angles measure 160 each? I've got two options here. Two options. I could do my 160 equals 180 times n minus 2 all over n. Or if the interior angle measures 160, the exterior is going to be 20. And I can just do 360 divided by 20. So 360 divided by 20, 18. I don't know why I did that. But anyways, 18 sides. How many sides? There it is. That's my answer, right? All righty. Cool, cool, cool. All right, let's keep moving. Ooh. Given DE equals 7 and CB equals x squared plus 13x, solve for x and which angles are congruent. Okay, so I don't have anything about DE and CB here in this problem. But let's see here. If I've got my two congruent segments, that makes D a midpoint, right? And that also makes E a midpoint over here. So if those two things are true, this is a midline, isn't it? Which means that DE is half the length of CB. It's also parallel. I've got some information about lengths. DE is half the length of CB. Or in other words, x squared plus 13x, that would be equal to 14, right? If I double DE, that would give me CB. Now I need to solve this. Oh my goodness. Is this another factoring problem? Mr. Allen, you dog. All right. What multiplies the negative 14 that adds the 13? X plus 14, whoop, and x minus 1. So I get negative 14 and positive 1. Those would be my x values. What does it ask for, though? Solve for x. Okay. So either one of those would be acceptable, and actually both of these would work in the original context of the problem. So there's my answer. Now the other part of this one says, which angles are congruent? We did mention the parallel aspect, right? Well, if I take these two parallel lines and I have this as a transversal, then these two angles are congruent. Angle ADE and angle C. Okay, I'm going to do this. Angle ADC is congruent to angle C. And then on the flip side, if this were my transversal, I'd have angle AED. Sorry, this should have been angle ADE right here. My apologies. So then I have AED is congruent to angle B. Those two angles will be congruent. I got my x values. That's it for this problem. All right, awesome stuff. Any cues? Any cues? I can't answer any questions here. It's a video. All right. The angle bisector of angles C and B meet to form angle D. Find the measure of angle D. So I don't have D on here. Apparently I need to draw this in. Angle bisector, angle bisector. So these two are congruent. These two are congruent, and they meet at point D. Okay. Find the measure of angle D. So we're looking for this guy right here. I'm going to explain this a little bit different than how I did personally in class. So I know that the measure of angle A is 70, right? What does that leave for angle at its time was, well, we'll call it angle ACB plus angle ABC, right? Angle C and angle B before we drew this all in. What should those two add up to then? Those two should add up to 110, right? Because if this is 70 up here, 110 is left over. Now, if I cut those two in half, right? If I cut them both in half, I don't know exactly what they're going to be individually, but I know when I add them back together after I cut them in half, if I divide this by 2 and if I divide this by 2, the halves are going to be 55 degrees altogether, right? So what we're saying here is this angle, angle DCB plus angle DBC is equal to 55. So now I'm dealing with this triangle here, and it's kind of like, let's see here. So these two angles will add to 55 degrees. So what's left over for angle D up here? Well, 180 minus 55 is going to be, drum roll please, 125? Hope that's right. Yeah, cool, awesome. 125 degrees is my answer for this bad boy right here. Good stuff. You can set it up algebraically with x and x, y and y. Some of you I've seen you guys are just thinking through it in this kind of way, but yeah, another way of looking at it. I think it's cool. All right. This is one of my last pre-made ones, then I got to start making more up off the top of my head. Okay. Find the angle, not that I just made these all up off the top of my head. Find the angle form when extending two sides of a regular octagon. All right, so it could be any pair of sides, but since it's not specific, I'm going to go with, this side here, this side here. And then what's this measure going to be right here? Okay, that's what I want to find out. Okay, I drew them a little long, but whatever. Well, how could I go about this? It looks like I have a triangle right now, right? I have this like triangle right here. Maybe I'll do that in a different color. How about with white? That kind of doesn't really show up. But I noticed that the pinks and stuff like that, they don't really show up that great. All right, so that's a triangle. Maybe I can use that. Can I figure out like maybe some of the angles of my octagon? Let's go with that. How can I find the measures of the, or the angles of the octagon? Well, one interior or one exterior. How about 360 divided by 8? That would give me an exterior angle. Ooh, isn't this an exterior angle, right? And isn't this an exterior angle? So if I got my exterior angle, 360 divided by 8, which is 45, both of those angles are 45. I'm going to enlarge this now. I have this situation going on right there. Well, what's left over for this angle right here? 90 degrees. So I went through by finding my exterior angles. You can do the same with the interior angles and find the supplement. But I found the exterior angles because this triangle, this angle right out here, when I drew a triangle on it, those two angles are exterior angles of the octagon. All right, just using what we know from exterior angles, what we know about some of the triangle angles. Oh, this is great stuff. Oh, yep, time to think of one. I'll pause. All right, the measure of the angles of a triangle are in the ratio of 6 to 3 to 1. Find the measure of the largest exterior angle. Ooh, okay. So if I've got a triangle and I've got the angles are 6x to 3x to 1x, right? That's what that's saying there. How many degrees are in a triangle? 180. Thought you'd never respond to me, but I appreciate you for responding. All right. So that all adds up to 180. So I got 10x equals 180. Oh, how wonderful. Easy to divide. I planned that. So I get x equals 18. So what that tells me now is that this is 18 degrees. All right, and then we got 3 times 18, that's 54 degrees. And then I got 108 degrees. I think that checks out. Yeah, all right. So what's the measure of the largest exterior angle? The largest exterior angle is going to be paired up with the smallest interior angle, which would be that guy right there. Okay, so looks like I'm going to have 162 when I find the supplement of that. So 162 would be my answer. I could have just asked what's the smallest angle of the triangle measure? That's 18. What's the largest angle of the triangle? 108. What's the smallest exterior angle? So on and so forth, right? A lot of questions we could ask here. That was pretty good, right? I like that one. That's fun. That's fun. Okay, another one. All right. In triangle LMN, L and M add to 80, M and N add to 100, and find the measure of all three angles. I'm going to draw a picture for this. And as we've done in class, it's not official notation, but if I see L and M add to 80, I'm going to throw an 80 out here. All right, I'll be like, hey, it's these two, right? And then if M and N add to 100, I'll throw that down here. Find the measure of all three angles. Well, let's backtrack a sec. If that's 80 right there, right, that means that the measure, hold on, pump the brakes. I need to change a number real quick. Let's make this 120. Otherwise, things are going to get weird, okay? All right. So if this guy, L and M, it adds to 80, then N, what's left over is 100 because there's 180 degrees in the triangle. 180 minus 80 is 100. Then I take into this refurbished value here, as you can see maybe why it was going to be wrong. This is 120 for these two. What's left over for the measure of angle M? Well, that's going to be 20, right? If N is 100 and they add that 120 together, that's going to be 20. And then I got 60 over here. Whether you said, well, two of them add to 120, subtract that from 180 to get 60, or if you were looking at this guy right here saying, well, L and M add to 80, subtract 20 from that and I get 60, that works too. Either way, we've got all three angles. We are good to go. All right, let's keep on moving and grooving here. Another lovely problem. Okay, I think I got one. All right, the moment you've all been waiting for, this one that wrecked many of you on the quiz, right? Oh my gosh, X's and Y's. Now something squared, bro, a quadratic. Don't even, man. You're going to throw that at me? Yes, I am going to throw that at you. Okay, so I've got this whole triangle. Within a triangle, we have triangleception, right? Inception of triangles here happening. Okay, so what the heck can we do here is really the question. Well, I've got some Y's here, right? And we've got another Y here and an X. So I could say like Y squared minus 4Y plus 8Y plus Y plus 3X. That all adds up to 180, right? And then I also have Y plus 3X plus 140 equals 180. And I can do a system of equations with a quadratic. You could do some substitution. It's going to get messy. I wouldn't suggest it. All right. What I would suggest, however, is trying to set up an equation only in terms of one variable. I can't do that with the X's, but I can do it with the Y's. There are a couple routes of what you can do here. And I'm going to go in the route that is maybe more related to what you might see on the test. So I have Y squared minus 4Y plus 8Y is equal to 140. How the heck did I know that? Let me isolate a part of this diagram, okay? Okay. So if I take this blue triangle off, there we go. I am dealing with the Y squared minus 4Y, the 8Y, and the 140. 140 is an exterior angle with the 8Y and the Y squared minus 4Y being my remote interior angles. Those two add up to that exterior angle. The sum of the two remote interior angles equals the exterior angle. That is what the equation is right there. Some of you might be thinking, could I have just gotten this to be 40 because these two are supplementary and then add all three of these up and set them equal to 180? Yes. But in the event that, say, the 140 over here and the 8Y were switched with each other, right? Now all of a sudden, can you really find a supplement of that if this was in terms of X or Y? No. So that's why I'm setting it up this way, okay? All right. Let's go ahead and solve this one now, okay? So I'm going to have Y squared plus 4Y minus 140 equals 0. And if I'm going to multiply to negative 140 and add to positive 4, what am I going to get? Will that be positive 14? I don't know why I'm like writing numbers backwards today. And negative 10. All right, I like that. So now I get Y equals negative 14 and Y equals 10. Negative 14. That's not going to work here, right? Because I got, nope. But if I put in 10 for Y, I get 80 up here. That's fine. I can check it. I get 100 minus 40 is 60 here, right? And that actually does check out because this would end up being 40 down here. You know, that makes sense because 140 and 40 should add up. But I also want to solve for X here. So Y is good. I got to eliminate this one. It does not work. But for X now, well, up here, that would just be 10 degrees, right? So now I have 10 degrees plus 140 degrees plus 3x equals 180 because of that little triangle out there, right? That really skinny triangle. So I'm going to have, let's see here, 150 plus 3x equals 180. So 3x equals 30, x equals 10. I've got y equals 10, x equals 10. That is a coincidence. They're not always going to be the same thing, as you saw in your quiz. Whew, that's a good problem right there. That's some solid, solid stuff. All right, let's do another one of these, and we'll call it a day. In case you're like, I really just want to try one on my own. Feel free to try this, pause it, do it. I think everything works out. Again, I just made it up at the top of my head, so we'll see. Let me get a drink. You've now had your chance to pause the video. We're going to get after it. All right. So I know when looking at this problem, I could set up all three of these equal to 180, but then I have x and y. I could set 6x. Hold up. Yes. Dang it. Sorry, I moved the 30. Otherwise, it's too easy. Actually, no, wait, never mind. I second guessed my intelligence. We're good. We're all good to go. Sorry about that, guys. I had some second thoughts there. All right. The only thing I have is that one little triangle there. I don't have anything for the whole big triangle, right? But with my exterior angle theorem, I could take x squared minus 26 and set it equal to the remote two interior angles, which would be the 6x plus the 5x. If we need to isolate this triangle, it's going to look something like this. This is my exterior angle with these two being my remote interior angles. Looks a little bit jacked up because it's not an obtuse angle for the exterior this time, but that is the situation we have at hand, okay? So now I'm going to go ahead and solve. I'm going to get x squared minus 11x minus 26 equals 0. So I'll have x minus 13 and x plus 2. So far, everything is checking out from doing this problem in my head. All right. X is going to equal 13 and x is going to equal negative 2. Negative 2 plugged back in would give me two negative angle measures. That's not okay. I'm going to work with the 13. All right. If I plug 13 in, all right, 13 times 6. I don't want to make any, little silly errors here. We get 78 here. That's cool. All right. Then I've got, 65 over here. Cool. And then I've got, that could be helpful, right? Or 13 squared minus 26 would give me 143. And just for fun here, what's 78 plus 65? 143. TI-84 confirms. All right. We're in business. So either I can say this plus this equals 180 and solve for y, or I know that these two are supplementary, solve for y. Either way, it's going to end up looking kind of the same once you do some combining of like terms, right? So I'm going to have 4y equals, and that's going to be 37? Okay. And then I'm going to divide by, so we're going to end up dividing. So 37 divided by 4 ends up with y equals 9.25. Cool. Got x, I've got y. Yes. All right, there we go. Sorry for the thought that I was going to switch, and then it all worked out. All right, that's what happens when you don't work through these first. I'm just trying to make a video for you guys so you can have a little bit of extra fun after school, because who doesn't love studying honors geometry? All right, American Freedom, Rock and Roll Costco, River Dog Jenny on the gram. Yo-Ro, don't forget, Yo-Ro, you only round once. Mathematical accuracy. And you guys have a wonderful day, and good luck on your test tomorrow or whenever you're watching this. Maybe in the future. Maybe it's going to be 2025 and you're still watching this. You probably are. All right, see you later.